Hello everyone. Today I'm gonna talk about is further kinematic, chapter 8 in book 2 applied. So first one, you see when you read the question, if you can you pause the screen and then read the question first, and then we can talk about it. So you should find is to find R exactly equal to integration of V dt. Now, if you really don't know the formula, sometimes you differentiate or integrate. Sometimes you just forget. So easy, just m, ms, and ms square. Now see that is every time you go down one step, you differentiate, and further down, you differentiate. But if you want to go reverse, you do reverse of differentiate, which integrate, isn't it? I and j, that's your choice. That will be equal to it, like normally like integrate respect to value of x, here respect to value of t. So you got a t square over 2 I plus 3t cubed over 3j. Of course you have to plus c, do not forget it. But c here had to be in terms of I and j also. So write c1 I as c2 j. That is respect of I and j here. Now after you've done this, you're going to carry on, which you do initially. Okay, here you are r equal I, so we're going to find out when t equals 0 initially, then r equal to I. That means that information here will provide us the value c1 and c2, and further down you can see I'm going to carry on. I'm going to substitute and I'm going to work out that equivalent to 1i basically and 0j, because that is r equal I here. So therefore I can see that c equal to, so c1 equal to 1 and c2 equal to 0, and we're done. Therefore r equal to t square over 2 I plus t cubed, because the 3 cancel 3 out on the top there, and add I. That's it, done. Of course, don't forget j here. You can write in a vector. You collect like term, make I as subject of formula out. You got t square over 2 plus 1, of course, I here, and plus t cubed j. So we have our equation. Here you are. Now I'm going to carry on. I'm going to do a differentiate v. So dv over dt, that equal to a. Now that will carry on work out when t equal to 4. So I'm going to start here, differentiate first. Normally you differentiate just easily. So you differentiate of that in respect of I and j. I'm going to carry on now, okay? Now the first I here, you differentiate respect of I, so differentiate I place, then respect to t, so equal 1, which is I. Okay, on there. That's it. Because differentiate of t equal 1 and differentiate of 3t squared equals 6t, make sure do not forget I and j here. Okay. Now after done that, when t equals 4, I'm going to carry on. Therefore a equal to, still there no respect, no value t here, so it's still I, and plus 24j, and that's done. So x-axis like this. So I mean 1 meter above means every single time is 1 meter above here, above 1 meter. So all the point on the top there. That means y value equal to 1. Literally y equal 1. So look at our formula you got here. That means when y equal 1, that means r, right, t cubed has equal to 1. That means t equal to 1. Now we're going to substitute to find the position right now is equal to r equal to would take 1 here, so therefore is 1 square using that formula here over 2 at 1 I plus 1 qj. That we have is 1.5 because 1 square is still 1 over 2 1.5. So 1 square over 2 is 0.5 at 1 equal 1.5 I at j. That we done the question number 1. I really want you guys gonna start is pause the video and then give it a try first. Highlight all the keywords as possible when you're ready, and then click play and see how you're getting on, guys. Carry on a different shape. Yeah. dr over dt. That give me v. So carry on. Or different shape here. Now you differentiate of each component. You see that? So you learn in Pure 2, which is second year pure math. You differentiate cos of 2t. So you differentiate cos of x, you got minus sin x. So you differentiate of cos of 2t, you have using chain rule, and you should be able to do it. Now imagine here you differentiate of cos 2t and sines. I write in column vector instead there, it's easier. Now do imagine here, I taught in the classroom sometime before, so that is whole u. So cos of whole u, you got is minus sines of whole u, but you times by u dash, right? Differentiate of u basically. The differentiate of 2t is 2, so therefore multiply by 2. Same thing here. Differentiate of sin x equal cos x, but here differentiate sin u, which is cos u, which is that is letter u, basically represent whole thing in u, times by u dash, which is differentiate of u, which is differentiate here equal to. Therefore my v I got is minus 2 sin of 2t. It's a quick way to work out instead of the carry on. That is the column vector, guys. I'm done. Okay. Right, now next one I'm gonna find a acceleration. You differentiate again dv over dt. Now so you can differentiate this one again. Now constant in front, which you can ignore it, so care about sin 2t, what sin u exactly. Differentiate of sin equal cos, so minus 2 still there. Differentiate of sin equal cos of u, say similar, but you must start by times by u dash, which is 2 again, which is differentiate of 2t. Same thing here for 2, differentiate of cos equal minus, so minus, yeah, sins of 2t, but make sure time by 2 as well, because that is differentiate of u. In the end they have a minus 4 cos of 2t, and here is 4 minus 4 sins of 2t. Okay, that's done. That a in terms of t. They're saying show that a equal to minus 4r. Well, you want to check the formula of a, and then you compare the formula of r, isn't it? So we can see that a, look at r, what r equal to. R, which is given in the question, cos of 2t and sins of 2t, and compare to a, which equal to that a vector, of course, minus 4 cos of 2t and minus 4 of sin of 2t. Now you see the ratio here, so you can need 4 loss of r minus 4 loss of r equal to a, so therefore a equal to minus 4r. That's done. Not only 1 mark anyway. It's quite easy, right? So part B done. Part C. Now r equal to when you substitute t equals 0 here, cos 0 equal 1 and sin equal 0, so basically is at the position here. draw a V loop. Here you are. That's it. So the position right here, y is equal to 1. Right here. Now, how about V? When is R equals to V, that it will be equal to here. Look at V formula, V equation. Yeah, V equation here. Is subject equals 0 here. I got is 2, 0 and 2. So you can see that is 0 and 2. Look at 0 and 2, the direction of velocity is across nothing, but you're going to go up by 2. That's a B. And how about A? Look at A formula, equation, not formula, equation. We work it from part A, and you can see that what A equal to, substitute equals 0 in there, goes 0 equal 1 to minus 4, and then sign up 0 equals 0, so equal 0 times minus 4 equals 0. Now you can see that the displacement is 0, 1. That means that is O here, so 1 here. You stay position right here. And V equal to 0, 2. Look direction of 0, no cross, but go up by 2. That V. Look direction of A. A go to left hand side because the position here, go left hand side by 4. So arrow go by 4. But didn't go up or down. Alright, you can pause and give a go and see how it's getting on. When you're ready, press play. Now you can see that is the ball here. Play first, of course. Up. Yeah. The fourth drag up in kV. Mean they are kind of proportion to velocity. And of course down here is mg, but m equal to 1 kilogram, so therefore g on it. And that's it. That's all you need to get 2 mark an exam. Read number part B. Now, they're saying you find the expression for V when ball is in equilibrium. So you're gonna start carry on. Even equilibrium means there is no go up or go down. I mean all fours are balanced, isn't it? So therefore is we need to solve it. So kV equal to G. Therefore V equal to G over K. So that's it. Done. That is 2 more. Okay, any exam? Part C. Y equals this. First of all, you see that the dV over dt, that the what we're looking for, basically equal to A. Isn't it? And what A, and what we're looking for is F equal ma, isn't it? You know the second Newton law. And when m equal 1, so F equal to A. Therefore, we've got a total force, total downward force, is G take away kV. Based on second Newton law, G take away kV equal ma. And reason why is m equal 1, A equal to A. That means it's called, that basically equal dV over dt. So that reason why the formula comes from. Okay. Part D. Show by the substitution that V equal to G over K 1 take away e to the power minus kt. Satisfy equation in part C. Now, when you do this question here, you have to use a differentiation to evaluate both sides. Okay, first left hand side first. dV over dt G E minus KT. G minus KV, and G equal to G take away K still there, times by V, which is G over K, 1 minus E minus KT. And that will give you is, expand bracket out, G minus G, and then minus become plus E minus KT. And the answer is equal to E minus KT. G gone. Oh, sorry, it's G here. Okay, part E, what does it say here, part E? Explain why this solution agrees with the answer in part B. Now, see, as t go to infinite, you see that v will tend to g over k. Like a terminal velocity. Now, if you want to explain clearly why this, because you can see here is you have to get the v out. You see, look here, like now you have to understand about reason why, because you have to care about e power minus kt. Based on index law, you can write 1 over e to the power kt. So when t go to infinite, then equal 1 over e to the power infinite, which give me infinite. So when over infinite, that tend to 0. That reason why v equal to g over k. Yeah, that is explaining reason why happening. Limitation of this model. You can get any limiting out. Basically, maybe I was saying about is the balls is not particle. The particle much better. It quite and then surface of the ball as well. Any reason, give me any reason why. Okay, you could say up thrust due to water pressure, drag proportional to the velocity, only at low velocity. With highest velocity may be different. So yeah, the limit there. Any example there? Done. Number 3. Okay, we start number 4. So I want you guys gonna pause the screen and highlight the keyword and give a go. And when you're ready, press play. Okay, number 4. So when you read the question, you see that highlight keyword is A, given by formula which is 180 take away 360 t. Now it is not constant acceleration, therefore you cannot apply Subat. That's very important. You have to find out when you can apply Subat. When A is constant, you can apply Subat. Otherwise, don't. Okay. Now find speed of the car when in terms of t. So to find speed, we're gonna work out is integration, of course. A equal to part A, B equal to integration of A dt. Now you're gonna integrate them out and see what you get there. So now you got integration of 180 take away 360 t. That will give me is 180t minus 360t squared over 2, the respective value of t. Now it will give you 180 still there, t. That'll give me 180. Take away 180t squared. And don't forget add what? Add c. When you integrate, you must add c. Okay. Next one. How am I gonna find c here? They say to you guys is start from the rest. That is the keyword. Start from the rest here. I mean v equals 0 when t equals 0. So t equals 0, v equals 0. That will work out is v equal 180 times 0 is still 0. So basically v equals 0. So c equals 0. So square and c. So basically e equals 0. So c equals 0. Next one. Okay, part B. SAT is the speed limit is 40 km per hour. Now they say find the range of the times during which car is breaking the speed limit. Alright, so we're gonna start here. B had to be bigger than 40. That reason why it's a breaking speed limit. Now that equivalent to 180 t minus 180 t squared. Sorry, reason why for v from beginning. I was talking part A, and I forgot how to finish yet. So 180 t minus 180 t squared on it because c equals 0 here. Alright, now we're going to carry on. Bigger than 40. So we're going to work out. Look, observe first. You can see that it's a good. Okay, so I'm going to teach you how to use calculator as well. Here you are. If you want to solve a question quick in exam, so get a calculator out, and you're going to be using the equation, which you here execute, and then you know that now the equation here basically quadratic. So using is polynomial. So f2 right here. Degree the power would be 2. So f1. So you see that you make them equal to 0 first to get the interception point first. So a equal to 180, and then b equal minus 180, and then of course c equal 40. And you work out here is t, the first one, not x. In here you write x, but here we know that t is 2 over 3, and that t equal 2. Down here, which is 1 over 3. So here you are. So I know that the quadratic smiley face intercept at minus 1, intercept at 1 over 3 and 2 over 3 here. Now you see that what part of the curve is below 0 because we're looking for less than 0 here, which is here. That what t value between 1 over 3 and 2 over 3. Therefore, the breaking the speed limit is t will be between 1 over 3 and 2 over 3. But in terms of hours, we want in terms of minutes. So do not forget that. Multiply everything by 60 to change to minutes. So time by 60 here. So therefore a third times 60 will give me 20 minutes. And a 2/3 of hour time by 60 give me is about 40 minutes. So time which is about 20 to 40 minutes is breaking the speed limit. Now next one, part C. We're looking for average speed of the car. Basically equal to total distance over time. Now we're looking for x first, of course. So x. Now again, for further kinematic here, you must able to do integrate different shape properly, and make sure you remember this here. Or m, which is represent for displacements, and of course m over s squared. But remember that you go down, you differentiate because of a rate of distance. Go up, you integrate. We should remember that. So we have a formula v. So therefore, we have a v here. To find distance, we have to do integrate. Integrate of v dt, which integrate of the formula of v, which is given about 180t, to 180t squared. So what will give me is 90 t squared minus 180 t cubed over 3, which is 60 t cubed. Okay, and of course, yeah, see. Okay, now after that, so t equal to 1, therefore x equal to x equal to 90. Now before doing SC here, but we know that it starts from the rest. When it mean is 0. Now, so t equal 1, x equal to 90 times 1 basically. So like 90, we'll quickly now. 90, take away 60, equal 30. Therefore, I have an average speed equal to 30 over 1, which give me 30 kilometer per hour. Okay, that's done. Part C. Find the mass. Find the acceleration of a particle when time t. Now, first of all, based on second Newton law, F equal ma. Now, so you're gonna carry on. 2 kilogram is a keyword. So we're gonna carry on is A equal F over 2. So therefore, every single component must divide by 2. So I got A equal to 4 2 t plus 3 minus 6 t squared. That belongs to A. And what next? V, integrate of A dt. Respect to t, therefore you integrate each component now. If you can see clearly here, you integrate the whole thing. Now, 4t at 3t squared. 4t at 3t squared. Because I see component did 4 times t plus 3t squared. And down here I have a 2t plus and minus become minus 6t squared. And dt, of course, when integrate each component now, I work into more column vector now. So I got 4t mean 2t squared. 3t cubed over 3 give me plus a t cubed. That is 2t be 2t squared over 2 give me t squared. Minus 6t cubed over 3 give me e. Take away 2 t cubed. And of course, don't forget part C1 and C2 here, of course. Now, what they say to you when it's t equals 0, v equals 0. So therefore, we substitute t equals 0 here. You know that C1 and C2 will equal to 0. Because here everything equals 0. Therefore, C1 and C2, both of them equal 0 vector. 0. Okay, now we have a v. We're looking for what? We're looking for is a position, which is displacement. But in vector position. Okay, therefore we're looking for r. R integration of v dt again, which is right into vector here. Integration of 2t squared plus t cubed and of course t squared minus 2t cubed dt. Now we're going to carry on. R equal to that is integrate of each component, on top component, bottom component, so separately, so that you got a 2 over 3 t cubed plus t power 4 over 4. That is t cubed over 3. And this one equal minus 2 over 4 t to the power 4. Of course, don't forget RC. Well, C1, C2, you can write B, whatever, it doesn't matter. Now, you know that it's a start from, let's say, origin. That means when t equals 0, R initial means R0, I always write it down, it's basic 0. So therefore, you can see that C1, C2 equals 0 also. Therefore, C1, C2 both equal 0. I'm going to carry on next. Now, they say to you next now is, I think I've done well for that, part B. You can simplify, that's your choice. It's really no big deal. Okay, now the last step, we just simplify it and then we're done. So, I equal to, you can write it this way, 2 over 3 t cubed plus t power 4 over 4, and second component, which is here, which is t cubed over 3 minus 1 over 2 t power 4. Now you can separate them out because t cubed, you can leave answer like this fine. No one wants to say anything. You still get full mark. But if you want to make it simplify for nicer, you take t cubed out, you can write a 2/3 here and 1/3 here, and a t cubed out. And here you could add. Take t power 4 out. You put 1 over 4 here still, minus 1 over 2 here. You have the t power 4. Basically the same thing. I used to go full mark for this one, and no one wants anything. Should be fine. 2 times 1 square plus 1 cube. So you should have is 3. 1 take away 2 is minus 1. And that's it. Okay. We should get an unit there as well. So v equal to 3 and minus 1. That's the final answer for question number 5C. Now, it's all done today. And there are 5 questions. Look at the scenario about the further kinematic. If you have any question, please write comment below. And make sure that you click like and subscribe. So next video clip, you won't miss my topic.